Okay, hey everyone. Uh, it's taken quite a while actually to make this recording because it took quite a while to get the physics paper on the SEC website for some reason, but it's here now and I'll be reviewing the physics paper. So it's the last physics paper of this particular academic series, which has been in place since I think 2003. So 20-year long course, and they end it with a bit of an odd paper in terms of what it includes in different places. But of course, I'll be reviewing every single question that's on the paper. So, starting off as usual with section A, starting with Boyle's law, which was one of the mechanics experiments I predicted. I was leaning more towards the measuring G by pendulum, which is totally okay. They both hadn't appeared since 2020, one of the COVID years. So they were bound to come up. It was a pretty straightforward question, though I'm pretty sure this is just meant to say V and not PV. Those who obviously sat the paper, if you can let me know of the erratum notices that were sent out, because they're not posted on the SEC website. But I'm pretty sure that's meant to read V. Unless I'm entirely mistaken. But a pretty standard question nonetheless. You just had to convert kilopascals and cubic centimeters into the correct units, but otherwise grand enough. But then, oh look, the period of a simple pendulum and verifying G by pendulum did in fact come up. So they've decided again to do two mechanics experiments, which is a bit odd, but for some students they don't mind it because practicing the mechanics experiments, of course, they are pretty much guaranteed to come up. So knowing a bunch of them that haven't been done in a while would have actually done you quite a good service. One thing you need to note is that the length is, of course, in centimeters, but pretty much everything else here is bog standard material. So a lovely, lovely question. Question 3, again, another one I predicted, measuring the wavelength of light using diffraction. So again, it's just a mix of really, really straightforward sections. So the label diagram, the method, precaution, the wavelength, and then two different things with just varying a couple of elements in the experiment. So, it was near enough a copy paste of a previous diffraction question. So actually really lovely in all these parts, and the bits of it you should have practiced before. So pretty nice question. And question 4, another heat experiment. This time it was latent heat vaporization. I was predicting specific heat capacity, so I got this one actually incorrect. But again, once you actually noted all the different parts, it was relatively straightforward. So the calculations here split into 3 was actually pretty nice, because the calculation without that is rather long. So it's nice that they split it into 3 parts. But the theory elements as well were actually not too bad. In question 5, resistance versus temperature. I wasn't actually predicting this at all. I put down resistivity as my prediction for the electricity experiment. Again, got it slightly incorrect. But again, if you've noted through all of them, you'll actually see that resistivity does pop up. So it's not resistivity in kind of the usual way where you have the ohmmeter the ohmmeter connected to 2 ends of a wire. But you shouldn't have been fully disappointed, because resistivity actually did come up in that part. So overall, the experiments in section A, apart from question 1, all had real bog standard bits to it. So the section A's, you should have been very fine. I also just realized that the resistance here is in milliohms, so just convert those back to ohms. So I really do rate the section A's, just the questions in section A, just kind of for their quality and easy predictability, which is one thing I will definitely miss when the new course comes in, or when the first of the new exams comes in for the new course. Now, section B. Right, question 6. Where do we even begin? It was a mixed bag of questions, so there were some fairly straightforward questions, like question A was actually pretty nice. Which other one? Question I was grand enough, and K and L pretty okay. I guess J to an extent, if you practice your modern physics, though they actually did give you the masses here. So you had to just include the plus energy term. That's on the end of the carbon-12 as it decays, but otherwise not too bad. The questions that I had slight issues with were part B. It's another moments question in a question 6, which appeared in 2024, and I'm nearly certain there's one in 2025 as well, though it might have been the moments experiment. But anyway, bit of an odd question because it didn't appear as part of a question 6 previously, as far as I can remember. So adding it again was a bit odd. Some other weird ones, part D and E. It's a bit weird, like part E, conceptually very straightforward, but trying to phrase obviously heat and temperature and their distinction might have been a bit difficult to try to get the full marks. And question H, slight overcomplication, but actually not too bad once you broke it down in the usual fashion, where you sort of deal with the this time the series goes first, and then you have a parallel section after that. But everything else, sort of when you're gathering the resistances on this, is actually not too bad. So question 6 was a bit of a mixed bag. You definitely should have found 8 questions. That would have been nice, like A, C, D, F, G. That's already 5, and then I, J, and K. Like, there's your 8. But I can tell, like, if you want to answer all the parts, then it would have been quite challenging, some of them. Now, question 7, mechanics. Started off actually not too bad. Like 19 of the marks were to do with 2 definitions, which you can use formulae for, and then a pretty straightforward derivation. And you'll see a lot of derivations actually in this paper, which is a bit strange. And then we have this setup, which is a weird, like, it's evidently slightly like introductory applied maths work questions, where you have sort of a hammer-like object hammering something into the ground. But once you sort of broke down all the individual sections, like here, it's just a SUVAT question. Here, also SUVAT question, conservation of momentum, and then the definition of the force, which were big indicators just from the first part of question 7, which you should use to your advantage. But actually, once you've done that, or not done that, but rather once you've noticed it, the rest of it follows suit. And then a pretty straightforward sound question, so just differentiating between sound intensity and sound intensity level. Stuff you should have seen before. Now, question 8. When I saw this, I was actually slightly proud, because I put focal length of a concave mirror as part of one of the mandatory experiments. So the students that I have went in knowing essentially mirror dynamics pretty darn well, and a question like that actually came up involving a concave mirror with some focal length involving the magnification and bits of theory. So actually 15 really easy marks for most of my students. And then a Schnell's window type of affair, which is fairly okay. It's a pretty standard question, though part 5 might have required a bit of thinking. But the rest of the parts were really quite manageable. Question 9, again, it's an absolutely beautiful question, this time in terms of sound. So actually the Light and Sound crew, who put a lot of time into studying it, or studying those sections, it actually would have paid off, because both of the questions were very rudimentary in what they covered, such as resonance and the experiment. That's about half a page and it's 15 marks. And then the fundamental frequency, these are bog standard calculations. I'm using the word bog standard a lot, but that's because a lot of the section B questions were just that. Just a bunch of fairly okay subparts to a particular main topic like sound or light. So if you practice a lot of sound, question 9 was absolutely beautiful and one that you should have done. Now, question 10. A lot of the students who came to physics grounds, they left out or chose to leave out electricity, which is fine enough, though I feel in this particular instance it was a slight bit unlucky. A pretty okay question involving capacitance. The only real hiccups were possibly part 2 in terms of describing the motion. of the electrons, which, if you understood the proper mechanics of a capacitor, is really straightforward. But those who might have just learned the formulae and what a capacitor is generally might have struggled. And then the graph element on this as well was admittedly slightly misplaced. You had to essentially form your line equation, rearranging for C in terms of D, and then the rest of it is constants, of course, because we're told that the permittivity is constant. This is actually just the permittivity of free space. I'm not sure why they chose to specify it again in farads per meter instead of the usual Newton meter squared per coulomb squared, but at least it's somewhat good that they specified that time. And then a pretty okay circuits question. So this is identical or nearly identical to a question that appeared in 2024. So for those who did practice more than two or more previous exam papers, you would have seen this question and you would have been absolutely fine, and two pretty standard calculations involved with it. Question 11, a question involving magnetism, and weirdly, a bit of light. I'm not entirely sure why they decided to include this weird section into the question 11, but sure, it's pretty much all a combination actually of modern physics and electrons, because of the fact that we have the cathode ray tube popping up. So we have bits of modern physics and we have bits of magnetism. And actually Fleming's left-hand rule decided to make an appearance. So previously it was just a case of it's on the course and people just go around doing that sort of weird symbolism involving Fleming's left-hand rule, but this time it actually would have paid dividends if you properly understood what each of the fingers stand for in the left-hand rule. And then some fairly okay sections, again, reiterating the cathode ray tube, and then an electron moving in a magnetic field. One just needs to remember that this is actually circular motion, though it is specified you did need to bring in circular motion equations into that particular part. Now, if one modern physics question wasn't bad enough, here is an entire question involving different elements of radioactivity. Now, there's a lot of parts, and even some of the parts have parts in them, which I never like. Having parts within parts, it just bulks up sort of unnecessary. Well, it makes the questions unnecessarily long, just having these parts within parts. Though, for those who used my table, so my table of information for the different types of radiation, this was fairly straightforward. Though this idea, so the principle of operation of a nuclear radiation detector, was a bit strange. I wasn't thinking that this could come up, but again, it does. So some of the things I predict come up do, but then there's a lot that I say it definitely will come up, and it suddenly has. Well, not definitely, it might not be, is the better word I should use. Part 4, fairly okay calculation. You just have to think a little bit between the two different isotopes of thorium. And then I won't spend too long kind of on the rest of it, because I know I'm getting a lot of time in this. But this is really straightforward in terms of radioactivity. You might have had to think just with the fact that there's a milligram sample. But then again, you just have to note sort of the interrelation between the decay constant and the half-life and this original mass. So actually not too bad of a question once you properly dissected it. Now, I think I've made my hatred for subparts within parts known, because I can tell that to some extent that the font in this question is so much smaller. And there's too many parts to it. Like, there's a question with a subpart, there's another one, and there's another one with 3 subparts with just a lot of different elements in it. It's like stretching from semiconduction to power to voltage time graphs into domestic electricity, and even the heat pump decides to make an appearance. Like, this is more of a question 6 than question 6, with just the amount of topics that this question 13 actually covers. It's a question that I usually recommend to students because, again, it's pretty much just like question 6's. You know, that those kind of short answer questions, or maybe just 1 or 2 calculations, but no, this is just pathetic. Like, the amount of parsing this. It's absolutely dreadful. I will definitely make my hatred note for that question. And I'll speed up a little bit. Question 14, pretty straightforward vectors question. If you did the 2024 deferred question 7, then this is pretty much the exact same, just adding vectors together. Part B, again, it's another copy-paste question, I think from 2018, I want to say, where they had the Doppler effect involving with circular motion. So that's twice circular motion has been asked in 2 very different contexts. So if you practice your circular motion, then again, your knowing of the equations was definitely very useful. Question C, again, not too bad of a question. So if you practice your static electricity, it's actually fairly okay. This question might require a bit of thinking, just the parts 4 and 5, the electric field strength due to 2 charges. And you might think this is actually the best question, although we haven't seen particle physics yet, and that's because they put it in question 14 for some reason. The last time this happened was in 2019, and we weren't necessarily predicting that they would do it again, particularly if it hasn't been done for 7 years. There was a time where it was a question 13, which wasn't too bad because it was still a full long question. But for those students who wanted a full long question on particle physics, you might have been left slightly disappointed. But other than that, it's a fairly okay question, just involving pair annihilation of a proton and the antiproton. Though this actually part 4 is a little bit strange, but actually once you cracked it, it was actually fairly okay to do. And I haven't a clue about this part B because I don't do the applied electricity option. Right, my overall thoughts on this paper after that very long almost rant about the paper, because there were a lot of elements, particularly section A and questions 8 and 9, that were actually relatively good. I definitely felt the students would have been able to sort of crack down those questions and kind of gnaw through them pretty easily. But there were also questions that were just overly superfluous with just so many parts to do in the one question. Again, I'm looking at this without actually having done any of the questions, so it might have been a case of, oh, it was just 2 calculations, and that's sort of really it. But just from a look perspective, it's just so much material. But anyway, this is the end of this type of physics exam. So next year it'll be the new kind where we won't have a section A and section B or the manager experiments per se. It'll be slightly different. So let's see how they end up going. Now, for the most people that I've tutoring, this is the end. This is most people's last exam. So go enjoy the summer if this is your last exam. Now, some students have DCG but sort of obviously applied maths after this. But yeah, it's one final push, and then we'll be ready to enjoy the summer fully.